Over MIT's multivariable calculus exam practice question. So let's show you the exam here. This is a practice exam, so it's not the real one. But we're going to go over question 3, which is this matrix problem. Alright. So if you want access to the full exam, it's going to be linked below with all the other MIT 1802 stuff, all the lectures. So yeah, let's get into it. So the problem states we have this matrix A, and it's equal to 1, 3, 2, 2, 0, negative 1, 1, 1, 0. Okay? And we know the determinant of A is equal to 2. Okay? So, and then we have A inverse is equal to 1AB, negative 1, negative 2, 5, 2, 2, negative 6. Okay? So it states we have to find A and B. So to find A and B, we need to find the inverse of this matrix. So we know how to do that. So we're going to compute the minors, we're going to flip some cofactors, transpose, and then divide by the determinant. Okay? So, well, we have our matrix. So 1, 3, 2, 2, 0, negative 1, 1, 1, 0. Okay, so if you look closely enough, we only need to compute 2 cofactors, and those are 2 and 1. So you can be a little clever about that. And then now we just need, so for 2, we're just going to delete that row and that column, which leaves us with a 3, 2, 1, 0. And then for 1, we delete this row, so that row and that column, which leaves us with 3, 2, 0, negative 1. Alright? So what we're going to do is take the determinant. So this first determinant here, that one's equal to, so that one's 2. And this one is minus, so this one's actually minus 2, my bad. And then this one is minus 3. Okay? And now we're going to use cofactors, so we know the rule is, let me plug in these minors real quick so we don't know what this is. Negative 2, negative 3. So it goes plus, minus, plus, minus, plus, minus, plus, minus, plus. Okay. And then now what we're going to do is change this negative 2, because a negative times, or negative gives a positive. So it'll give us here, so we know what this stuff is. It'll give us positive 2, and then negative 3. Okay? And then now we're just going to transpose it, which will give us the matrix. This matrix, so 2, negative 3. And then now we're just going to divide by the determinant of A, which is 2, so 1/2. Okay? And then we'll get A inverse is equal to 1, 2, negative 3, negative 1, negative 2, 5, 2, 2, negative 6. So we found A is 2 and B is negative 3. Okay? That's part A. Right, part A. Let's move on to part B. So part B gives us this system, so AX is equal to B. Okay, where X is equal to this matrix X, Y, Z, and B is equal to 1, negative 2, 1. Okay? So we have this form here, and what we can do is take the inverse of a to get x, right? Because we're going to try to find x, y, and z. So we're just going to, so x is equal to a inverse times b, okay? And we know we can just, so we have a inverse, we already solved a inverse, which is, so we have 1, 2, negative 3, negative 1, negative 2, 5, 2, 2, negative 6. And then we have b here, which is 1, negative 2, 1. And then now we're just going to compute this, which, so this gives you here, it'll give you 1/2 times negative 6, 8, negative 8. Okay. Alright, so now what we're going to do is just simplify this out. It'll give us negative 3, 4, negative 4. Okay. There you go. There's part B. It's self-explanatory. Okay. And finally, we move on to part C. Okay. Part C states we're gonna let some A, or let's let A replace the 2 in the upper right hand corner. So in the matrix A, it's 1, 3, but in this case the 2 over here it's C. You get 2, 0, negative 1, and 1, 1, 0. Okay. And then we're gonna find a C that makes it invertible. Okay. So this is equal to some matrix M. Okay. And now we know whenever determinant 0 is invertible. Okay, so we need to make this 0. Well, now we just take the determinant of M. So we define it. So determinant of M. So we get 1 times 0, negative 1, 1, 0, minus 3 times 2, negative 1, 1, 0, plus, and now we have this C times 2, 0, 1, 1. Okay. So the determinant of this is just 1 minus 3 plus 2C. Okay. And then, so give us negative 2 plus 2C. We will get C is equal to 1. So when C is equal to 1, this function, or this matrix is invertible. Okay. Now, we have one last part of it. So for this value of C, which we have is 1, we have this system Mx is equal to 0. Okay? We're going to find a solution for x. But we know straight off the bat 0 is a solution. So we're going to find another solution. So we're going to have this, we have x plus 3y plus 2 is equal to 0. 2x minus 2 is equal to 0, and x plus y is equal to 0. Okay? And for a solution to be this, all these things have to be sitting in the same xy plane. Okay? And now we have one of these equations redundant is as we have a determinant of 0. Okay? So now we're just going to write it in the components. And then we'll get 1, 3, 17 for this first one. That's equal to 0. We'll get 2, 0, negative 1, my bad, is equal to 0. And then we have 1, 1, 0 is equal to 0. Or, yeah, it's equal to 0. But what we're going to do is we're going to cross product this. So it's I hat, J hat, K hat of 1, 3, 1, 2, 0, negative 1. Okay? And when we compute this, we'll get -3, 3, 6. There we go. I hope you enjoyed it. If it helped you, that's great. And comment down below if you want to see me go over the whole exam, because these problems are pretty interesting. So make sure to like, comment, subscribe. Have a great day.